Yesterday we saw the standard equation of a parabola. Yeah, conics we finished. Conics we finished and we went to parabola and we saw the standard equation of a parabola. You remember the standard equation of a parabola? What it was? What is that? Y square
is equal to 4ax.
X. Okay. So you remember what all the thing we did?
So first directrix.
Yeah. So first no, the axis. We will draw the axis, na? What we draw.
That's a direct.
Yeah. See something like that. The directrix is like this. This is the directrix. Okay. And this was a parabola you draw. You remember that? Something like this. And here is the. This is the midpoint focus. Yes. And this is a point P, x comma y. Okay, so what you know is this distance is equal to this distance. Correct? So this is also midpoint and this is a O. Am I right?
That is M. The point of the directrix. M.
Ah, okay. This one? M. Okay, whatever it is. So this is our x-axis, this is our y-axis. Okay. So if this distance is A, so you remember this point is what? A comma 0. Correct? And the equation of the directrix is what?
X equal to y. X is equal to A.
Minus A, na? This is 0, na? X equal to, so we get it, x is equal to minus A or x plus A equal to 0. X plus A equal to 0. Okay, so then this is the parabola of this shape. Okay, so we saw this is what you call as a right-handed parabola. So now we saw for the left-handed parabola also, isn't it? What was the left-handed parabola? How we did? The same thing, we took it in the other side. So let us call this as your axis and this is a axis. So this is axis and let this be the directrix. Okay. So and do you remember what was the equation for that? Y equal to minus y square equal to minus 4ax. So actually, you remember what we did is we took the focus S and then the point P, x comma y, and then this is your M, and then this is your focus. These are equal and these two are equal. So A, okay. So this is your S will become minus A comma 0. So this will be this point is A comma 0. So your directrix will be what? X is equal to A, so x minus A equal to 0. Okay. So now, there's a simple way you can, then you find out the distance, we find it. There's a simple way you can do it out. See what happened when you are swapping. See, so this is a parabola, right? You rotate the parabola with the axis like this. So then it becomes right-handed, correct? So what changes when you rotate it, what happens? All x becomes negative x, correct? So in the same equation, you replace x with a negative x, what you are going to have is a left-handed parabola. The same thing, it's not. Suppose I rotate it like this.
The y will.
Correct. So then what happened? Your x will become y and y will become x. Correct. So then that time what happened when you rotate the parabola like this? So what happened? You. Yeah, correct. Exactly. X square equal to.
4ay.
Yeah. So you can 4ay in your book they written as 4by. Just to make sure that's a different. Okay. So this is your S and this distance will be your B if I call, and this is your directrix. Okay. So this is for this point will be what is this point? 0 comma minus B. Am I right? So now, so the whole thing, this is the same thing you rotated it. Am I right? So simple, you replace your x with y and y with x and that's what you are. So in this case what happened you think will be x square equal to 4by. Yeah, correct. So 4b, b is just a constant. It can be a also, doesn't matter. In your book they are written as 4by. Now, if I rotate it like this,
the negative sign will change.
What sign? Which sign will this? Y sign will change, right? So then what happens? This will be
X square.
when it exactly reverses it. So then that's something like this. I'm going to draw. Okay, let me draw a different color so it will be easier for you. So now this is a parabola. This is a parabola and this is your directrix. Correct? So and this is your focus S. That's equal to 0 comma minus B. Okay, so it's exactly opposite. So y becomes negative. So then in that case what happened? Your x square equal to minus 4b, minus 4by. Okay, so this is what they given in your book. So they written all these things. Okay, the getting the form is simpler. Okay, so now, so this is a different, some standard form of parabola. This standard forms of parabola. You can, so if you remember, all these parabolas remains, means you can, basically what happened, doesn't matter. What a parabola, when we say parabola, what is a parabola defined? The locus of a point which is equidistant from a fixed point on a straight line, the Directrix, right? So in this case what happened, we taken, this is the fixed line and this is the fixed point, the locus of the point. It not necessarily has to be there. We can have the fixed line here and the fixed point here. Similarly, you can have the fixed line here and the fixed point here. So all possible, everything is parabola only. It's a way how you are going to represent your directrix and the focus. Okay, so that's what it decides your parabola. So these all are standard forms of parabola. Now, okay, let us take out the, so it means you deal with for one parabola, that is going to be same for all the other parabola because it's just a rotation only, changing the rotation and changing the axis. Okay. Now you tell me, so will this parabola, okay, so let us draw, this is the parabola, right? I am going to remove all these guys. I will remove this one and we will have only this. Okay. Now tell me, will this parabola be symmetric?
Yes.
Why it's symmetric? Tell me. From here, can you tell why it will be symmetric? So tell me, what will be your y? From here, y will be equal to plus or minus root of
4
2 is there, na? 2 into root of ax. Correct? So what it says, for every point x, how many y's you will have? So let us say for every point x, this is a 1 point x. This is how many x's, how many y we will have? 2y. One is a plus 2 root of ax and another one is minus 2 root of ax. So similarly for all the points you have the same thing. Am I right? Okay, so what it means? It's basically symmetric. Every point, just exactly the symmetric one. Alright? So therefore, so your parabola will be symmetric around the axis. Okay, that's what they written in your book. What they written is, the equation of parabola can be written as one is for every, okay, so the parabola is symmetric about the x-axis, not necessarily. If you draw like this, symmetric about the x-axis. If you draw in the left hand, it also will be symmetric around the x-axis. But if you take it your y-axis, then it will be symmetric around the y-axis. Okay, it is symmetric around the axis. Okay, in this form, it's symmetric around the x-axis. For okay, yeah, this is okay. For see, for example, here in this case, if suppose x is less than 0, that means x is, you are taking, so this is a parabola, x less than 0 means here. Okay, this is imaginary. You got it? It will be complex because minus of square root of minus. So that is the, for x is less than 0, the value of y is imaginary. Therefore, entire part of the curve lies on the right of the y-axis. Therefore, it won't happen on the negative. This point will not cross the negative, it will always fall on the right hand side. Similarly, for the left hand side, you remember yesterday we did. You don't go into right hand side because it was minus 4ax. So, x has to be negative side. Always become imaginary. So, the curve will always fall on the either this quadrant or this quadrant. Sorry, in this positive x or negative x or positive y or negative y. Okay. So, okay, fine. Intersection of the intersection with axis. Okay. Just tell me where a parabola intersects with the axis?
In
Origin, that's what. Okay, but remember that's always, this is not always correct. When you have a shift the origin, we will see that. Okay, general form of parabola. Here we are taken, we choose the origin to be at this point. Remember, because this axis we only draw.
choose it as a directrix.
Yeah, somewhere else, then it is going to be different. Okay, this is it, because the parabola equation says only directrix and the point. It defined by only three quantities: point, focus, directrix, and the locus. So given these two, this is what your locus of a point. Okay, fine. Okay, shape of the parabola, that's also interesting. Okay, now you tell when x goes to infinity, y will be? When x becomes infinity, or from here it tells x is equal to infinity, y also will be infinity, na? It can be either plus infinity or minus infinity. So that means this parabola, will it be a closed curve?
It will be infinitely.
It will go open, it's a infinite, okay, and not like ellipse and circle, they are closed curves. Parabola will never be closed, it goes up to infinity. They never meet each other. Okay, so that's what. Okay, and now, okay, then what they have done is some results. Focal distance. Okay, so remember, and this all, what am I going to do for focal distance, all these things, I am going to do it for the right-handed parabola. But the same thing can be done for all the other parabola also. Okay, the same. Okay, so let us see. What is the focal distance? Tell me. Focal distance is this. Any point on the parabola, and the distance of the point between the point and S is what you call as your focal distance. Okay, so tell me what will be the focal distance. Can you find out? Because how to find out the focal distance is simple. Because in a parabola, these two are equal. Am I right? So this distance is going to be equal to this distance. Okay, so you know this point is xy. So what will be this point? Tell me. What's the point M?
So it will be.
This is 0, na? So this is minus a, correct? Minus a comma y. Am I right? So let us find out this distance. PM distance will be your SP, and that's what your focal distance, right? So focal distance what is that? SP is equal to PM, and that will be equal to what? Tell me the distance. How much is the distance?
X minus a whole square.
X plus a, na, minus. So x plus a whole square plus y minus y, that is 0, right? So x plus a whole square, correct? So this makes it equal to square na. What, you're having square na? Square root. So it will be x plus a.
Okay, correct.
Got it? It should be actually plus minus x. Plus minus should be there. But we are saying about a distance. It's a length. Length is always positive, magnitude only. We don't call this negative. Got it? So, the focal distance. So, focal distance of a parabola is what? X plus a. Okay. Now, can you tell me what will be the focal distance for a right? It will be the same because of magnitude only, na? Okay. And the same when you, because it's a magnitude, it's a length. It's not going to make any difference. It's right here at the length. Now, what about when you write in the y-axis? Are you sure?
The x will be y.
Yeah. So y plus b. It become y plus b. Okay. So that's what your focal distance also. You understood now what is the way. Okay. And that there is a point they have. Correct. Okay. And okay. So they have only for these two. Fine. Okay. So this is the focal distance of the parabola. Okay, what it says, a plus your abscissa, x abscissas. Okay, abscissa of the point P. Then the length of lattice rectum. Do you know what is lattice rectum? Okay. You know what is lattice rectum? You should read all those things. Okay. So what is lattice rectum is? So it has a focus. Am I right? So these questions they may ask in your exams. So this is a focus, correct? Draw a perpendicular. at the focus. So the length of this chord is what you call as your lattice rectum. Okay, so let us call this region as L. So then the lattice rectum will be 2L. Am I right? So let me call this as, what is that we are having? This is P. Okay. So let me call, no, this is P is different. Let me call this point as, say something, what point?
Q.
Q. And this point be P. QP is a QQ prime, let me call. Okay, so the distance between Q and Q prime, or distance between Q and S is your lattice rectum. Okay, so how will you find out? How will you find out L? Tell me.
We took the coordinates of Q, but
Hmm?
we need the coordinate of Q.
Correct. So tell me how will you get it. So I'm going to remove this point also. This is not the right point now we have. Correct? So now we have to find out the coordinate of the point Q. Correct? So tell me how we are going to get the coordinate of point Q. So you can use any property.
So the first one would be A, comma.
What will be this length? This also will be L.
That'll be L.
Am I right? Is that L around? Correct?
Okay, so that'll be L.
So then what will
It's
be
a
this point?
parallelogram. It's a
Okay, that's a parallelogram. Of course, I understand it. I'm not telling it's not a parallelogram.
No, if it's a parallelogram, then we already got the angular length of L. It will be
Correct?
A
Tell me.
2A.
What
L will
is
be
it?
2A.
Exactly. That's also you use a parallelogram also. That's why also in your book they have not used that way. What the book they did is, so this point is what? How much will be this point? So this is L. So L, sorry, this is L. Okay. So sorry, this is L. So this will be what? This is what will be this point? X will be minus A, comma L. Okay. So and this point will be A, comma L. Find out the distance. Okay. So yeah. Since y square equal to, okay, otherwise what they have done is, so what they have done, this point is A, comma L. This point lies on the parabola. So then what happens, since lies on the parabola, what is the parabola equation? Y square equal to 4ax. Now this point lies on it. So this point satisfies. What is the y? So L square equal to 4a, x is what? Into L, a. Am I right? So L square equal to 4a square. So L equal to 2a. There will be plus minus. It's a length. Okay, the length of the lattice rectum. So it's L. So therefore, your lattice rectum QQ prime will be twice 2L, correct. So it's 2L, that will be equal to 4A. 4A, correct? And that's all for your, okay, then there is the activity. Find the length and end points of the lattice rectum of the parabola x square equal to 8y. How are you going to do that? Tell me.
Length and end points.
So see, whenever you write down the equation of the parabola, that should clearly hint you what sort of parabola it is. Okay. For example, what the parabola they given is x square equal to 8y. So this parabola will be what shape? Where?
The y-axis.
Yeah, it will be like this. Am I right? So what is the parabola? Let us draw the parabola we have. So the exam you don't have the time to draw the parabola and all. Okay, so you should. This is a parabola. Okay, so this is your x square equal to 8y. Okay, so what is the general form of that parabola? X square equal to 4ay. Okay, so 4a is equal to 8. Therefore, a is equal to 2. Got it? So now you tell me. So what is the point they have? You got A.
L will be.
Correct.
L will be.
What is the L? L will be what? L is this one, right? You have, this is the S. Correct? So the L will be equal to
4 into 2.
Yeah, right. Because total L, 2L, na? So let us call this. So the length of lattice rectum. will be equal to
2L.
2 times L, that's equal to, and L will be equal to what?
2A.
2A, and that will be A is equal to 2. We are going to have 4. So 2L will be what equal to what? 2 into 4, that will be equal to 8. Okay, what is the question they asked? The endpoints, the length we found out, endpoints of the lattice rectum also you have to find out. You have to find out these points also. Tell me what will be this point?
So the focus will be 0.
Yeah, right now this is
0, 2.
So this should be A. Correct? So what will be the L we have? L will be 2A. Correct? So this is 2A. 2A. Am I right?
Okay, with that itself we got the point.
Yeah, of course. This is what?
So that
2A, comma A, and this is
minus 2A.
minus 2A, comma A. So, the endpoints of the lattice rectum, okay? End points of lattice rectum will be equal to what? One is minus 2A, comma A. Okay, so what is minus A we have? What is A? A equal to 2. So this will be what? Minus 4, comma 2. Minus 4, comma 2 and 4, comma 2. And that's what your answer is. Okay, got it? Okay, and there's one more problem they given. What's that? Okay, let me remove it off. Then only you'll be able to find it. But the point they give, the second problem they given is find the same, the length and the endpoint of the lattice rectum for the parabola 5y square equal to 16x. Okay, so what is this form? This is basically right-sided.
No, it's not right. Okay, right.
Of course, right-sided. Na? So what I can write? I can write as y square equal to 16 by 5x. So this is a right-sided one. So now we have general form of parabola is what? Y square equal to 4ax. So 4a is equal to 16 by 5. Tell me what is a?
4 by 5.
A equal to 4 by 5. And that's it. Now you know what are the points. Tell me what is the length of the lattice rectum? Tell me.
4A. 4 entire lattice.
Length of lattice rectum. Correct? Will be equal to what? That is equal to 2L. Exactly 2L. And L is equal to 4A. Okay, 2A. So it becomes 4A. Am I right? So 4A. 4A is what? So that is 16 by 5. Okay, and the endpoints of the lattice rectum?
We can use it from the previous question, right?
Exactly, the same thing. What happened here? There we have end. So L is equal to 2A. You got it? So what is this is what? This is A, comma. So this point will be what? L is 2A, na? We got it, right? This will be A, comma 2A.
A, comma minus
2. A, comma minus 2A. So we have A. A is 4 by 5.
4 by 5.
So will be what?
4 by
A. 4 by 5, comma
2A, right? 8 by 5.
8 by 5 and
4 by 5.
4 by 5, comma minus 8 by 5. Okay? That's all your answer is. Cool? There is a table given in your book okay, where they say when you write the parabola in these two forms, one is along the x-axis, along the y-axis, how these quantities are going to change. Okay, there is a table given in your book. So I will just read the table so you can see. Okay, the first one is y square equal to 4ax, that is like this. And second one is x square equal to 4by, that will be like this. Okay, so the focus, of course, you know, the focus for this case it is a comma 0. Here it is 0 comma b, correct. Equation of the directrix, what's that? Here it is x plus a equal to 0. Here it will be?
Y plus.
Yes, exactly, y plus b. Yeah, you call b equal to 0. Vertex, of course, the vertex is going to be 0, 0 for same. N points out lattice rectum, that also we found. N point here is 1, yeah.
X would be y and y coordinate would be
Yeah,
x.
exactly. That's also given. Length of the lattice rectum 4a, in this case 4b, if you call it as b. Okay. Axis of symmetry. In this case, axis of symmetry is x-axis.
Exactly.
Here the axis of symmetry is
Y.
y-axis. Equation of axis, of course. So the equation of the x-axis is equal to y equal to 0. This is x is equal to 0. Fine. Tangent at the vertex, of course. So for this parabola, tangent at the vertex is nothing but a y-axis. For upward parabola, the tangent is your x-axis. That's right. Focal point of the parabola, focal distance of the parabola, that also you know. X plus a, remember the focal distance. That will be same, irrespective of, x plus a or x plus b, magnitude only. Okay, so that's what they have done. And the next one, this is interesting, parameter form of writing the expression of, this is what is parametric expression for standard parabola. Okay, so what happened? You remember what we are doing is, so what it mean is, so we had this parabola. Okay, and this is what? Y square equal to 4ax. Now, I am giving any one point. So what will be, you write it x1, y1, right? Can you write this point in terms of a? As some coordinate. Okay, so that's what you call as your parametric expression of a parabola. Every point you express in a. Okay, so that's form. So what they say is, there's one thing you have to know about parameter. They give a definition of parameter. If the coordinates of a point on the curve, correct? If the coordinates of the point on the curve are expressed as a function of a variable, another variable, okay, and that variable is called as a parameter for the curve.
That will be just like a comma 2a, right?
Oh no, a comma 2a is a constant, one point. Not all point will be not a comma 2a. That is a comma 2 is a lattice rectum endpoints. That is the a comma 2a is a lattice rectum, na? You got it. See, that is your S.
It is so perpendicular.
This is what a comma 2a you have it, not all points. Okay, but what you are asking here is all the points. So the way you can write is, suppose you write x equal to at square and y equal to 2at. Okay, so now you see, if you write in this form, this is basically nothing but this. Why? You take, so y equal to 2at. So what will be y square? 4a square t square, correct? Or 4a into at square, correct? At square is what? X. Y square equal to 4ax, that's what a parabola is. So in a way, every point, so when you introduce this variable t, which they call as a parameter, the moment you introduce variable t, then you can define every point on the parabola as in terms of t. What is that? at square comma 2at. Now you keep changing t. For different t, you get all the points. This is you defined the whole parabola points in one single variable t. You got it? So that's what you call as your parametric expression of a standard parabola. Okay, cool. So, okay, they are given on some problems, activities. So let us see. For the parabola, y square equal to 12x, find the parameter for the point A, 3 comma minus 6. You have to find out the parameter. What is the parameter? This t you have to find out. Simple, na?
We have to find the a.
Correct. So, of course, what is the form of this equation?
Y square equal to 4ax.
So y square equal to 4ax. Therefore, 4a equal to 12.
A equal to
So, therefore, a equal to how much?
3.
3. Correct.
Three
So, now a
divided
equal to
by
3.
the-
Yeah, right. So, now we have x, right? 80 square equal to 3 and
280.
280 is equal to minus 6. So, now we find, tell me, what is a equal to 3. So, 3. 3t square equal to 3, therefore t square, t equal to plus or minus 1. And here 60 equal to minus 6, so t is equal to minus 1. So of course you take only one value, right? Both the values. Therefore, we have t is equal to minus 1. So the parameter for this parabola t is equal to what they ask? Find the parameter for the point, this one. The parameter for the point t is equal to minus 1. Okay, similarly they want to find out for another one also. Find the parameter for the same parabola. Find the parameter for the point 27, 18. Of course, a is going to be the same parabola. Okay, so what we have, 80 square equal to 27. So this says a equal to 3. So t square equal to 27 by 3 equal to 9. So t is equal to plus or minus 3. And similarly, 280 equal to 18. Am I right? So therefore, tell me what is t?
60.
This will be what? A is equal to 3. 60 is equal to 18. So t is equal to 3. So therefore, t is how much? Equal to 3. Not minus 3. Okay, this is all the one. Okay, there's one more problem they given. I will do that also. What they given is y square equal to 16x. Of course, it's a very simple parabola. What is that? Y square equal to 16x from here. Okay, and what you do? You want to find out the parameter for the point 9, minus 12. Find the parameter of the point. Parameter means you have to find out t. Correct? So general equation of parabola is what? We have y square equal to 4ax in comparison. Therefore, we have 4a equal to 16. A equal to 4. Okay. So now tell me, what is that? At square will be 9. So, and a is equal to 4, right? 4t square equal to 9. Therefore, t is equal to
root of 9 by 4. That is
3 by 2 plus minus. Am I right? So now next one is what? What is the next one? Y value is 280. Correct? 280 will be equal to how much? Minus 12.
So 8 equal to
This is what? 8. Correct? So 8t is equal to minus 12. Or t is equal to minus 12 divided by 8. Tell me, how much? 3 by 2. Right? So therefore, t is equal to minus 3 by 2. Therefore, the parameter t is equal to minus 3 by 2.
Instead of doing for 80 square, we can just do for 280 and do that.
You can do that way also, of course. For the completers, you have to do both. you can, of course, you can do there, but I don't know whether the teacher will give mark. Okay, so that's all about your parametric expression for a standard parabola. Okay, so now let us go for one more thing. The last one I am going to do, with that I will stop. Okay, okay, this is important. General form of the equation of a parabola. See, remember, what you had done is, we have taken the choice of an origin as the vertex of your parabola at the origin, right? Not necessarily. You may have a parabola, so you may have an axis like this, okay, and the parabola may sit like this. That's also a parabola. Okay, because origin may, because this is respect to, because parabola doesn't say or where the origin is. It all says there is a locus of point equidistant from a fixed point and another straight line. You have no idea where it is, right? So this can be like this also. How are you going to, general form, how will you write it? So if you remember in the straight line chapter, so we had this shift in origin. You remember what is shift in origin? The straight line. So what happened? You have this axis. Say, let us call it as x and y, and there is a point. Let us take a point P is equal to say some x comma y. Now I am going to define another axis, another coordinate system, that is something like this. They call it as x prime and y prime. So with respect to this coordinate system, this point P is going to be x prime and y prime. What is the relation between x prime and y prime? Do you remember that? So what is that? So if you say, if this point corresponds to h comma k in this frame. Okay, let me write it in blue color. The origin of your red coordinate system, okay, if this is h comma k, so then you know what all these points will be.
X prime will be x minus
Yeah,
h.
so what will you do? So you have, so this is, yeah, this is what we will do. Am I right? So this length is your x prime. Sorry, y prime. Huh? So this length is your y prime, and this length is your k, and this total length is your y. Okay, so what's in y equal to y prime plus k, or y prime equal to y minus k. Same way you can write it this one, right? So tell me, what will be? This length is equal to x prime.
H. Oh, okay.
This is h.
Okay.
This is h. This is the origin we are saying. Okay, h, and this is I call O and O prime. Okay, O prime should be written in red. So this is your O prime. Okay, and tell me now what this length will be.
X.
This is your x, right? So x is equal to x prime plus h, or x prime, the new coordinate system will be x minus h. The same thing we have to use. Okay, so what we are going to do, we are going to use the same method. I will define a coordinate system.
Okay.
Am I right? So this is the point. So every point I define with respect to this. With every point I can define like this, right? So if I know if this point corresponds to, if this point is h comma k, then I can express the whole point in terms of this. Am I right? So that's what your coordinate is. So then what happened? So well, so let us, so for this frame, okay, let me write it out. So for this frame, so let me call this as your we will call this as your x prime. Huh? X prime and y prime. This is x and this is y. Okay. So what is the equation of parabola for in terms of x prime frame? Y prime square equal to 4a x prime. So now you represent in our actual frame. You want it in this frame. Am I right? So what it will be? So now you tell.
Y prime is equal to
so
y minus k.
Exactly. So now we have y prime. So we have y prime equal to y minus k. So we are going to have y minus k whole square equal to 4a into x minus h. This one. Right? So this is what your general form of a parabola. Okay, where x and k will be where the origin. This is origin, vertex. Given a vertex of a parabola, which is h comma k, the general form of parabola equation will be going to be like this. Okay, in fact, what you will see is, so you let us open this. Okay, so what will be, when you open it, what happen? Y square plus k square minus 2ky equal to 4ax minus 4ah. Okay. So let me, they written, this should be form. Okay, from there, we can write here as, so from here we can take, okay, so let me take here 4ax will be equal to, let me take this side, so y square plus k square minus 2ky
plus 4AH.
plus 4ah. Okay, so let me take 4a here. So x is equal to something 1 by 4 a y square minus 2k divided by 4 a y, right? Then plus 1 by 4 a into k square plus 4 ah, right? You can write this as x is equal to a y square plus b y plus c, where a, b, c are just some numbers, right? So this also, if you, this way also you can express your parabola. Okay, so that's what you written there also. Well, that's it. Okay, and now let us do some examples. Okay, obtain the equation of the parabola with its, yeah, okay, fine. Let me write down this problem. You have to find the equation of the parabola with its axis parallel to y-axis. Okay, what the point given? Axis is parallel to y-axis and vertex at h comma k. Well, tell me now, when an axis is parallel to y-axis, what is the general form of the parabola? X square equal to 4by. Am I right? So this is what we have, because we are having x prime, this is, because it's a prime frame. Okay, so now we have to write out. Now vertex is given, so what it will be? So x prime equal to x minus h and y prime equal to y minus k. So we are going to have, tell me, x minus h whole square 4by minus k. That's all. Okay. So if you want, you can expand it further. That's it. They don't have anything. That's all you have done it. Fine. So, and the next one, find the coordinates of the vertex. This is an interesting problem. So given the line, given the parabola, you have to find out the coordinate of the vertex. Find the coordinates of the vertex, focus, and the equation of the directrix of the parabola. Yeah, now they are given the parabola. So now you tell me, this is interesting. What is the parabola? Y square equal to 4x plus 4y. Okay, so of course this parabola is in a general form like this, isn't it? You can see. So what you have to do, how we are going to do it is, take, so basically you want to write it in this form. The one simple way is what happened, you have to write it in this form. Basically y minus k, right? K whole square equal to 4a into x minus h. This way you have to write it. Okay. So let us write down this, how we are going to do. So let me take this 4y here. So what are you going to, y square plus, minus 4y. Yeah. Y square minus 4y equal to 4x. So now you want to write it in this form. Am I right? Can I add any number and subtract any number? Y square minus 4y plus 4 and minus 4 will be equal to 4x. Correct? So what am I going to do? I am going to take this plus 4 here. So then it becomes, minus 4 here. It becomes plus 4.
So this will be y minus 2 whole square.
Minus 2 whole square. Very good. So this is going to be 4 into x plus 1. Am I right? So this will be equal to, so what will be your vertex? Tell me.
K equal to 2.
Huh?
K will be equal
Yeah,
to 2.
correct. Tell me what is it? So therefore vertex is what? Therefore the vertex h comma k will be
minus 1 comma 2.
minus 1 comma 2. Correct? Yes. Okay. So, and what else you want to find out? Focus.
Okay. Focus. The equation for focus is.
Simple, na? This is this form of same equation. Now, what is the focus here? Tell me. In your earlier case, what will be the focus for this point? You remember the focus, na? For the normal, for this coordinate, focus will be what?
A comma 0.
A, 0. Am I right? So, A, you got it from here.
A plus H.
A equals, see.
It will be A plus H.
Yes, exactly. A plus H. So, focus will be in respect to this frame. Any point as it A plus H.
Comma 0.
Yeah, A plus H and comma K.
0. It will be K.
K. Am I right? This side is K. Correct? So, therefore, you got idea, na? What is therefore the focus is what? Will be A plus H, comma K. Okay. So, what is A? Tell me from here.
1.
A is 1. Right. So, we have A equal to 1, H equal to how much? Minus 1 and K equal to 2. Therefore, the focus is
0 comma 2.
Is, tell me,
0 comma 2.
0 comma 2. And now the last question, so this is equation of the directrix. Directrix. Okay, so remember, what is the equation of directrix? This is, okay, sorry, this is not the equation of directrix. You have it here, am I right? Of the same length here. So, this is going to be minus A comma 0, right? So, equation of directrix is what? X plus A equal to 0.
So, X will be, it's not X, it's X prime, right?
Yeah, exactly. So, X prime. Tell me what will be equation of the directrix?
Minus A plus minus
X plus A equal to 0, correct?
X prime plus A equal to 0.
Is what? Tell me, X prime
plus A
is X prime plus A equal to 0. So, we know X prime is what?
X plus H.
X prime will be, no, X minus H. X minus H plus A. A is what? 1 should be equal to 0. What is your H? H equal to minus 1, right?
X plus 2 equal to 0.
Yeah. Therefore, this case, so H equal to, we have H equal to 1. Therefore, this is X plus 2 equal to 0. That's what your equation of a directrix. Got it?